Okay, so for today's class, we'll continue with the last thing that we did. In the last class, we understood the weight components along the plane and perpendicular to the plane. Okay, we now know how the forces work, about the equilibrium and F is equals to ma. The logic, the basic thing, everything is complete. Now we have to move on with the application based questions. We slowly increase the difficulty, definitely. So right now, the most, yes, I think the basic question that is coming in my mind is for a level plane, and this is a block of mass which is, let's suppose, 5 kg, and there are, let's suppose this is a force of 200 newton. There's another force of, let's suppose this is friction, F max. I told you friction is F max. Most of the time I use this, we use this nomenclature. Let's suppose this is 70 newton, and there's another force which is pulling it at an angle, which is, let's suppose, 25 degrees, and this is, let's suppose, 50 newton. This is a question which I have made up, so if you don't get very logical, very reasonable values for the solution, don't worry about it. Okay, in the exam you'll get very calculated, logical, reasonable answers. They would ask you to find the normal reaction force and the acceleration of the particle of the box. Okay, everything that I have given you. First of all, what do? You always identify all of the forces that are acting on your object. Right now, three forces they are showing to you. There's a 50 Newton force, there's a 200 Newton force, you have friction F max. What they have not shown you and what they will never give you is the weight. You have to identify this thing yourself. So weight would be always mg. So 5 times g. And definitely there would be a normal reaction force due to the floor. It would be acting perpendicular to the floor upwards, opposite to the weight, always upwards. Normal reaction force is always perpendicular to the plane, always perpendicular to the plane. Write this down somewhere. Normal force is always perpendicular to the plane. This is something that people don't pay attention to. This will always be perpendicular. Okay, so you have drawn the two forces which were not shown, and now we have shown it. And what you need more is also to break down your forces into components. So the horizontal component for the 50 Newton force would be the, I told you that the component along, sorry, adjacent to the angle, it is always cos. So 50 cos 25, and upwards it is 50 sine 25. Okay, now definitely vertically this object won't start moving, right? The object would not move up and down. It will move horizontally. So vertically the sum of forces is 0. So this means that the sum of the forces which are upwards would equal the sum of the forces which are downward. So upward forces are the normal force plus the 50 sine 25. The directions are very important, and this would be equal to the weight, which is 5 times g. So now if you want to find the normal force, this would be 5 times g. G is usually 10 or 9.81 minus 50 sine 25. So you'll use this in your calculator. Find the answer. 50 minus 50 sine 25. In degree mode, okay, 28.87. 28.87 Newton. This is the first part of the question. You have found the normal force, this force. How much the force is being exerted by the ground on this block so that it is at equilibrium in the vertical direction. Now, horizontally, the sum of the forces, we have to find it out. And the sum of the forces horizontally, we don't know if it is 0 or not. If it is 0, the sum of the forces in the horizontal direction, this object will be at equilibrium. Otherwise, we know that this is the resultant force and this would be equal to F is equal to ma, right? The mass multiplied by acceleration. So the sum of forces, how many forces do you have horizontally? Your sign convention, we use right side to be positive and left side definitely to be negative. Sign convention, this is very important. You fix your sign convention so that you use the same reference for all of the vectors. So horizontally you have 50 cos 25 in the positive direction, so positive, plus 200, which is also positive in the right side, minus F max. F max is actually stopping it, right? It is opposing the force 200 Newton and the 50 cos 25. So this would be negative 70. And definitely this is not going to be 0. So this would be equal to F is equal to ma. M mass is your 5 kg and this is your acceleration. So what you would do? You would do this. The next step is just use your calculator, find the acceleration. So 50 cos 25 plus 200 minus 70 and then divide by 5. So this has a very large acceleration, 35.1 meter per second square. This is not very realistic value, but this is how you would do. My values, this is the question which I made myself. So well, the answers is not very realistic, but the method is very, very good right now. The thing that I want to make you understand is how to find the acceleration if the resultant force is not 0. If the resultant force is 0, then definitely acceleration would be 0. If it is not 0, then this is how you find the acceleration. Okay, any questions? Anything? Toharan,
No, sir.
Nadia, Murtaza,
It's clear, sir.
Ammaz.
No, sir, no questions.
No, sir.
Good, good, good. Take a screenshot, or if you have any questions, ask or write it down. Anything that you feel is important. Otherwise, we'll move on to the next example. Sometimes now they can move around these things. Sometimes they would give you the acceleration, they would ask you for the resultant force, and they would ask you for the unknown forces. So this thing would be interrelated. Everything is now connected. Okay, let's do one more. Let's suppose there is a force acting like this at 60 degrees. We don't know the force Pn. The mass of the object is, let's suppose, 2 kgs. Okay, and friction acting on this object is, let's suppose, 15 Newton. And acceleration of the object is 1.5 meter per second square to the left. Now they ask you to find the value of P and the normal contact force. Now it's the same concept, is the same, but now something is given and the other thing is now they're asking to find out. Initially they asked us for the acceleration. Now they have given us the acceleration and they're asking you to find the unknown forces. This is another good example. The method, the logic, everything is same. So what would you do? First of all, you would identify all of the forces acting on this block. So you have the weight, definitely. Even if they don't give you, you have to identify, which would be mass times gravity, so 2 times g. And you have the normal contact force, definitely, which would be acting upwards. And if you break down the force of P into its component, so vertically downward, it would be P sine 60. the component opposite to the angle is always sine, and this one would be I don't have very much space. This is P cos 60. Now we know that the object is moving in the horizontal direction to the left. So this means the sum of forces in the horizontal direction is equals to ma, because there is a resultant force that is causing this acceleration. Okay, so this is equals to ma, and the sign convention, don't forget your sign convention, this is positive to the right side sign convention. So the forces horizontally, there's a what do we say, this friction to the right side. So friction, we take it positive right now. Okay, it all depends on the sign convention. Okay, now right now the friction is acting to the right side, so we keep it positive. It will not always be negative. Okay, it depends on the sign convention. Sign convention is very important. And then plus you have p, sorry, minus p cos 60, isn't it? Because this cos 60 component is acting to the left side, so the force of this, the direction of p cos 60 would be negative, is equals to, there's no other horizontal force, is equals to ma. So m is 2 kg, and acceleration is also negative 1.5, because again acceleration is to the left side. I have to, if I take something as a sign convention, this would be for everything, the forces, the velocity, the acceleration. You don't just use something else for the force, something else for the acceleration. Okay, so according to the sign convention, acceleration also to the left side, so I keep it negative 1.5. Now I solve for the value of p. So 15, and if you solve this, it become 2 plus 1.5 is equals to p cos 60. Cos 60 would be half, so this would become how much? 2 plus 3 is 8, sorry, 15 plus 3 is 18. 18 multiplied by 2 is 36. So p force is 36 newton. This force is 36. This thing is very important, how I generated this equation. And if this same question is coming in your exam, this would be at least of 4 marks, 3 or 4 marks at least. 3 marks at least, yes. Because this sign convention, the using and identifying the forces and everything is equals to ma, this is sometimes critical. Okay, you found the value of p. Now you can find the value of normal contact as well. So we know vertically this object is not moving, so definitely resultant force would be 0. It is at equilibrium vertically. So vertically up, you have normal contact force, plus you have no plus, you have is equals to, this normal contact force is equals to p sine 60 plus 2 times 10. P, we know it is now how much? 36 sine 60 plus 20. Use your calculator. This is coming out as 51.18 Newton. This is your final answer, the complete question. Okay, any questions, anyone?
All clear, sir.
Good. Sign convention, that is very important. If you understand this thing, then it would become easy. Okay, moving on, forward. Let's suppose this is a car. Not a very good drawing, but assume it is a car. And it is, the engine is exerting a driving force, okay, upwards. There is a force of friction acting on it. Let's suppose it is 0.75 of the driving force, the same as the driving force. The friction force is 0.75 or 0.6, let's suppose 0.6 of the driving force. Weight, the mass of this car is 1250 kg. The angle of inclination, let's suppose this is 16 degrees. They can ask you, find the driving force if the car is for suppose first part is at equilibrium, is moving at constant velocity, or if it is accelerating upwards at 0.8 meter per second square. Okay, so we have two cases. We'll solve definitely for both of them. Forget about the normal contact force right now. We will find it out if need be. Otherwise, that's easy. We can do that right now as well. Okay, let's just add it. Find the normal contact force as well. Normal force as well. Okay. Again, so first of all is to identify all of the forces. We have the driving force, we have the friction force. Apart from these two forces, definitely there is weight acting vertically downward, which would be 1250 G, right? 1250 G. And because of the inclined force, this weight is now being distributed into two components. One is along the plane, and the other one would be perpendicularly into the plane. And I told you, we have done this previously, that the component parallel to the plane is mg sine theta always, and this one is mg cos theta. And there would also be one more force, which would be the normal contact force, which would be exerted by the floor on this car. Normal contact force, N. These are all of the forces you have identified. This would be perpendicular. The normal contact force would be perpendicular to plane. So now the first case, we have to find the velocity of the car if it is moving at constant velocity. Constant velocity means acceleration is 0. And if acceleration is 0, then resultant force, the sum of forces would be 0. So this means that the forces which are pushing it upwards, and the forces which are pushing the car downwards, they both are equalizing each other. So you have to equate them. So the forces which are pushing it upwards, it is the driving force, which you don't know, is equals to the forces which are pushing it downward. It is the friction, 0.6 times direction, this what was it, driving force, plus the weight component, which is mg sine theta. So what do? Driving force minus 0.6 driving force, this is the F max, okay, this is the friction, is equals to mg sine of 16. So 0.4 driving force is equals to, use your calculator, and the 0.4 would go on the other side and divide. So how much will this be? Use your calculator. 12500 sine 16 upon 0.4. Sorry, 0.4. 8613. 8613 Newton. This is the force of the engine exerting on this car right now, which is overcoming the friction force and overcoming the weight component. Exactly overcoming the weight component and the friction force, so that it is at equilibrium and the car is now moving with a constant velocity. If this driving force was a little bit less or more than that, then the car would be definitely either moving up or down or slowing down. It would have a positive acceleration or negative acceleration. Right now, it is exactly at 0 acceleration. So we equate the two, upward acting forces and the downward acting forces. Okay, for the second part, now they have given us that the acceleration is upwards. So we have to use again your sign convention. The sign convention mostly I use is that upwards. If something is going upwards, I take it positive. So everything which is upwards, acceleration, everything for forces, I would take it positive. So F is equals to ma because there is acceleration. Vertically upward forces, not vertically upwards, along the plane upward forces, the driving force, which keep it positive, minus the friction force, which is downward, right? It is acting down the plane. 0.6 df, negative 0.6 df, minus mg sine theta, 1250 times 10 times sine 16. Any other force? No, there's no other force acting parallel to the plane. So this would equal to ma 1250 times positive 0.8, because I have taken positive to be moving upwards up on the plane. And this, the question is that the acceleration is upwards. So I take this acceleration positive 0.8. Okay, it is moving upwards like this. So this is the equation that we've gotten. And then we just have to use the calculator. So 1250 multiplied by 0.8. Okay, plus 1250 times 10 times sine 16. This we are getting 4445.46, and this is 0.4 df. So df is equals to this answer, complete answer, divided by 0.4, which is 11,113 Newton. So look, now the driving force is greater than the friction, and it is also greater than the weight component. It is overcoming. The driving force is actually overcoming the weight as well as the friction, and it is more than those. So that's why it is producing an acceleration. The car is speeding up now. Okay, for the last part, the normal contact force, there are only two forces that are acting perpendicular to the plane: the weight component, which is acting down to the perpendicular to the plane, and the normal contact force. So normal force is equals to the mg cos theta, which would be 1250 times 10 times cos of 16, which would be how much? 12016 Newton. This is your final answer. Complete question. This is a very past paper like question. Okay, so if you understand this, this is a very good sign. If you have any questions, ask. Don't worry about it. Okay. Any questions? Any questions? Otherwise, copy this down. Okay. Okay. So I'm giving you a situation right now. Okay. Try yourself. I'm over here right now in front of you. If you have any questions, you can ask. We'll discuss. Okay, we'll stop the recording. But this is something for you people. Let's see. Do it yourself. DIY. There was once a time then when I used to watch these things and was very, what do you say, amazed by the things that the video showed. DIY projects. So 5 degrees, okay, only 5 degrees, and now there's an entire truck. Okay, it is slightly. Let me change the situation. Okay, the truck is now coming down. Okay, its acceleration is down, and it is 0 point. Let's suppose the acceleration is 1.13 meters per second square downwards. The mass of truck, it is, let's suppose, I don't know what is the average mass of a truck. 20,000 kgs. Okay, let's suppose 20,000 kgs. And there's a force of friction acting on it. F max. Okay, they're asking you find the value of F max. Okay, this is the complete solution. This is a complete thing. Everything is given. Okay, don't worry about it. Just identify all of the forces that are acting. Give the proper sign convention. Use proper signs, positive, negative, according to that sign convention. And then let's see who gets the right answer. Okay, I'm stopping the recording. This is for you people. Discuss amongst yourself, or if you want to try yourself, try this, and then share with me whatever that you've done. Stopping the recording now.